Geometric series. There is a formula that we're going to use for this, and unlike the arithmetic series formula, there was kind of a story behind that. There's no real great story behind where this formula comes from. It's really just a lot of algebra that I don't even think we're going to spend the time going through. I'm just going to give you the formula. To find the sum of a geometric series, we use the following formula. A1 times 1 minus r raised to the n over 1 minus r. Please copy this down. A sub 1 times, in parentheses, 1 minus r raised to the n all over 1 minus r. That's a good question. The common ratio, because that's what we have when we're dealing with geometric series. R is our common ratio. And I don't think I have to define anything else because A1 we've been using first term, n the number of terms. I think we're going to skip over the next part. It's really just a lot of algebra that actually would have kind of created this formula. Maybe we'll look at it later, but I want to just start using this thing. So the first geometric series that we have is actually written out in full, but we're going to try to use the formula to figure this out, and then we'll check it just by adding up all the numbers we see and make sure the formula actually works. According to my formula, 1, 2, 3, 4, 5, 6, there are 6 terms. So this is S sub 6 equals. What's the first term? 3. Okay, so 3 times in parentheses 1 minus. What's the common ratio? 2. Remember, that's always what you're multiplying by to get to the next term, and if that's not obvious, you start doing some division. The second divided by the first, the third divided by the second, and so on. Raised to the n, how many terms? 6. All over? Not at all. 1 minus 2. Now, every year, students tend to find this formula to be the most difficult to actually type in on the calculator. I don't think it was super difficult to fill in. But I'm going to recommend when you go to the calculator, you don't actually try to type in all this whole thing at once. I'm going to recommend doing it in 3 separate steps to make sure that the order of operations works out properly. I'm going to start by doing what's inside the parentheses. I'm going to do 1 minus 2 raised to the 6th. And I'm going to push enter. I've got negative 63. Right, this is why I'm going through this, because that's not the right answer. Then, I'm going to multiply by what's out front. I'm going to multiply by 3. Negative 189. Then I'm going to divide by, I am not, watch this very carefully, I am not going to say this, divide by 1 minus 2. I need parentheses around. Sure, we could say divide by negative 1, or 1 minus 2, as long as it's going in parentheses. You should get 189.
So you could do my theory, but then just subtract.
That does. As long as you're careful with parentheses, you can. But again, there's a reason I'm showing it like this from what I've seen in the past. You don't have to listen to me, but you do get points for getting the correct answer. And this should not be super difficult. It gets a little more involved when the ratio is either a fraction or a negative number, so I need to make sure we can see those. Let's take a look at S sub 12 over here. Okay. Oh, by the way, let's actually make sure this one worked. Take a moment, add up those terms. Please take that out of your mouth. Please add up those terms just to make sure it actually did work. Let's add them up. They add to 189?
191, but yeah.
Okay, the next one thing I do want to comment about this formula. Did you notice how we went and used that last number like we needed for the arithmetic series? How I used the 96? Did you see how I used the 96, the last term in my formula? Hold on. Do you see? You're thinking way too hard.
No, it's not.
Do you see the number 96 in the formula? We didn't need to use the last term, which means if I give you something like this, I don't have to first go and use a sequence formula to find the last term. I actually have everything I already need right now to go straight to my geometric series formula. Question?
I mean, kind of.
What's your question?
Well, there's already a 6 in the exponent, and 3 plus 1 plus 2 plus 2 plus 1 is 9, so it would be 96.
That has nothing to do with this. Let's take a look at the next problem, S sub 12. Do I have a first term?
Yes.
What is it? Negative 45. Okay. 1 minus. What's the common ratio? And be a little bit careful. Preston. Negative 3. If you're not just seeing this again, please do some division. 135 divided by negative 45. Negative 405 divided by that. Now, just like our geometric sequence formula, we do need to make sure we put that negative 3 in parentheses. I did notice on the quiz some of you didn't do the parentheses, which threw off your final answer. Anytime the ratio is negative or a fraction, it needs to go in parentheses. Over 1 minus negative. Well, but that's the problem. Order of operations says we have to do the exponent first. And negative 3 to some power will sometimes be negative and sometimes positive. So don't do any of that. Just write out the formula the way I have it. And then let's go to the calculator. Again, I'm going to do this in 3 steps. I'm going to do 1 minus negative 3 in parentheses to the 12th. Make sure the 12th is outside the parentheses, and the parentheses are just around negative 3. After that, I'm going to multiply by negative 5, and then I'm going to divide by, in parentheses once again, 1 minus negative 3. See if you can finish that off. You look like you have a question. Negative 45, sorry. Negative 45.
What's the, oh my god. I'm right. What's the answer? Wait, can I say my answer?
5,978,700.
5 million.
Not get that.
Okay. Then
Oh wait, it's because I put the negative 3 to the 4th instead of the 12.
use the 12.
Don't know
Does
why
anyone
I
need
did
me to take a look at how they're typing this in? I don't think the formula is hard to write out, but it is tough to type in to make sure everything is working properly.
No, I'm gonna put everything in parentheses.
That really is the answer. Okay,
Put a parentheses.
the next one. I really think we should be starting all these by deciding is it arithmetic or geometric, but since this is the geometric section, yeah, they are geometric. On the quiz, though, and on the test, that will be the first thing you have to decide. Is it arithmetic? Then do what we did yesterday. Is it geometric? Then do what we're looking at now. This is geometric. What's the ratio? 1/3. The formula. See if you can write out the formula. And then actually see if you can do the whole thing. Being careful with your parentheses.
Tuesday.
Whatever the calendar says, I don't remember offhand.
I got a syntax error, is that right?
Then that means you typed in something wrong.
Square it.
I would prefer to try to get a fraction answer, and I think all of your calculators should be able to make this decimal into a fraction. Sometimes it won't be able to, then we'll just leave a decimal, but this one we should. Please put that back. Math, and then enter, enter. It should be able to turn that into a fraction.
121.
That's not correct. Let me start typing things in here. So I'm going to start by doing 1 minus. 1/3 to the 5th, and I'm going to put that in parentheses. 1 minus 1/3 to the 5th? No?
Wait,
Okay,
stop.
I didn't get the right answer.
Hold on. Hold on. I'm starting with the inside. 1 minus 1/3 raised to the 5th. I'm then going to multiply by the number out front, so I'm going to multiply by 1/3.
Dude, you slow down. Okay.
I'm then going to divide by, and again, we need parentheses. Actually, we probably even need 2 layers of parentheses here. 1 minus 1/3.
Wait,
That's a layer.
divide by.
Divide by, in parentheses, 1 minus, and then we should probably put more parentheses around the 1/3. I'm getting 0.49794. Then I'm going to convert this to a fraction. Math, enter twice. This is 121. over 243. Sam? Yep, so you should have like an F to D button. First of all, did you get? No. Let me just show you in general how we do this. 5/8.
Yeah, no, we learned that.
5/8. One of those four fractions.
It was when it was like X cubed.
F to D. Second. That letter.
Oh, with like balances.
5/8. It gives you a mixed number then you do second, and that can be a mixed number into the proper fraction.
I did the little thingy.
Because of this thing over here. We don't want to actually, I don't know where that is. Okay. We're going to do 1 minus 1/3 to the 5th. Then, you're going to multiply this thing. I'm just going to say answer times 1/3. I'm then not going to retype that in. I'm going to say the answer divided, because once you type it in this terms of the surrounding, it won't let it convert to a fraction. The answer divided by, in parentheses, 1 minus 1/3. Then it should work. Don't see the answer, type it in, and then use that. Don't copy it. Use the answer. If you just say divided by 4, the last thing you had, the answer is divided by 4. Okay. Yes.
Look at that.
Get them bridges on.
What is C period?
What is that?
No, it should be 1 minus 1.
Oh, yeah.
Great. Okay, so this is not how we're going to be able to actually get to any activities. If I want to help one person with the calculator, it doesn't mean you all start talking and causing trouble. Just sit and wait. Yes, exactly. Next thing I'd like to look at, we're going to skip the sigma notation just for the moment, and we're going to go on and look at the word problems. Then we'll go...
Can you like divide that or whatever?
That's what I've done over here.
No, like the 1.1.
Hit map, enter.
Right, 121 over 243 is that decimal.
Oh, got it.
But again, I wanted this written as a fraction, so you need to be able to convert that.
Map, enter, that's 2 steps.
Then leave it as a decimal and lose a point on the quiz. Shreya.
On a quiz, will you tell us when you want to?
I always want, if there are decimals given in the problem, then a decimal answer would be okay. But if there are fractions, I would like you to try to give fractions unless the calculator won't let you. But for something like this, all the calculators should be able to do that. Let's take a look at page 19. We'll come back to 17 in a moment. Please read the first problem. Don't do any math yet. Just read it.
Wait, we read like a...
Read the first problem on page 19. Just read it.
Take interest.
So the first month she is depositing $400.
Wow.
How can we figure out how much she'll deposit the next month?
Well, you're going to simply take 400.
Plus 400.
Okay, so 400 times 0.1, 10% of 400 is $40. Okay. How much is she depositing the second month?
Some of that.
440.
So it would be
Times 1.1, really, it's really 110% of what she deposited the previous month. So this really means at the end of those 2 months, she doesn't have 440 in the account. She has the 400 she initially deposited, plus the 440 she then deposited. What would she deposit after the next month?
484.
484. Again, 110% of what she deposited the previous month, and this is going to continue like this.
Oh, she's putting that in.
Yeah, so it's not like this is how much is in there. This is how much more she's adding in. 10% more than what she put in the previous month.
But then you get a...
So, I'm going to stop with this. This is forming a geometric series. There is no common difference between these. Add 40, add 44. You're adding different amounts every month, but there is a common ratio. What is 440 divided by 400?
1.1.
What is 484 divided by 110? Which I think makes some sense if she's depositing an extra 10% every month, which means every month she's really depositing 110% of what she deposited the previous month. So we can go use our formula. S sub, we're dealing with this after 12 deposits. S sub 12 equals. Do I know my starting amount? 400. Okay. Do I know my common ratio? 1.1. And what's the n? How long am I waiting? For the next 11 months. So it's really a total of 12 months, because we have the initial 400, divided by 1 minus 1.1. I will once again recommend you do this in 3 steps on the calculator to make sure the answer is correct. But then please type it in. And when you're done, because it is money, we will need to round to 2 places. It is.
How could she put this much in each month?
Because she was planning on putting in just 100, but maybe she worked a little bit more at her job that makes tips as a waitress or something. So she gets a little bit more. And then,
$1,000 in a month?
not at all. Every month is 400 plus a little bit more. This is the total she is making by the end of the year, not how much she's making that 12th month, but add the first month's payment with the second. That's why it's adding up so quickly.
I was about to say.
What you're talking about is finding the a sub 12 problem, the last number in the sequence. We want to find the sum.
He gets 400 a month, you make that in a weekend, please.
I'm making these.
I am getting $8,553 and 71 cents.
Yeah.
Can you get that? Try the next problem. Try the next problem on your own. It absolutely is. Jalen, please stop talking. Try the next problem on your own. Sort of.
Big number, just the 495.
It'll actually be easier if you leave it, because in the beginning there are fewer decimals to deal with.
Would the ratio be 1 point minus 1.9 or just 0.9? 0.9.
Katie, where's that coming from?
Oh, we just subtracted that.
Where did you get? So it's like the second month they're not depositing the 100% they initially did. They're just depositing 90% of that, 10% less. Similar to how we got the 1.1, we were adding that to 1. If you feel like you can do this problem without first writing out your terms, that's fine. But I can't actually give a lot of partial credit if you get the ratio wrong and don't have the terms there and don't have the work. But if you think you can get the ratio from just the words, like Katie said, the 0.9, you're welcome to just do that. We need the first term, the ratio, and the number of terms. So if it's dropping 10% every year, that means really every year it's 10% less or 90% of what it was before. If you don't like that, let's just go and actually write out some of the terms here. This is the first year. Let's find 10% of that. And then let's subtract that from what we were starting from. So it's like the second month, this is what we're depositing, which is 90%. And if we start doing our ratios, yeah, we're going to get 0.9. Wait, so you're getting an answer that's bigger than what you started from?
2.3 million.
Wait, I have that too.
I'm getting 2,319,367.05. How could that possibly make sense? Because that's less than what we're putting in. No, that's not. That's way more than what we're...
That's 6 years.
that's
Divide
added
by
up.
6.
Because it's the sum. It's not just finding out how much you're putting in the 6th year, which, yes, would be less than that. But it's the sum of those 6 amounts. Shreya.
So for the first problem, is there a difference between like adding them all up and finding like how much money she makes per year?
Please throw that away. Because this is just getting distracting now. The difference between the two examples of the first one is they were depositing an additional 10% every month, so I used that 1.1. Here, you're depositing 10% less, so I'm using 1 minus. Really, this kind of goes back to our percent increase and decrease problems where we had the 1 plus r thing and the 1 minus r thing. That's really what we're doing to get our actual rate here. Okay? Please turn back to the previous page, and I'd like to take a look at 2 or 3 sigma notation problems from the previous page. Page 18. So hold on a moment. Let's take a look at this first example. I'm going to first try to write out a couple terms to see what's going on here. So I'm first going to plug in 1. I'm going to get 6 times 2 to the 1 minus 1. That's just 6 times 2 to the 0. What's 2 to the 0? 1. So that first term is 6. The second term, plug in 2. We're going to get 6 times 2 to the 2 minus 1. That's 6 times 2 to the first. That's what? 12. I'm going to plug in 3. 6 times 2 to the 3 minus 1. That's 6 times 2 squared. No. I just want to do enough to get us started, and then we're going to learn the shortcut. Does this look like it's a geometric series?
Yes.
Okay. Now, first of all, say that again? It's just multiply by 2.
Well,
There.
I'd divide by a half.
That's not. We could do that. That's not going to be so helpful. Now, Preston.
That looks like an explicit formula.
It does look like an explicit formula. There are a couple things I need you to notice here. First of all, when our variable is in the power, it's going to be geometric because our explicit formula for a geometric sequence was that n minus 1 thing in the power. It's actually going to work if it's just n or I or whatever in the power or anything else in the power. But if I have something in the form, the sum as I goes from one number to some other number of, I'm going to say a times b to the I or something like that, that's going to be geometric. But there's even a little more I can get from my formula. What did we see the common ratio was?
Divide by half.
Enough, Nathan. Common ratio is 2. Do you see a 2 in the formula?
Yeah. It's right below the I.
The base of our exponential part, the thing we're raising to our power, will always be the common ratio. Which actually means I'm not really going to have to write out many terms at all. I'm just going to be able to get that straight from the formula. The thing we're raising to our power is our common ratio. So I'm ready to go use my geometric series formula. S sub, how many terms are there? 10. As we go from 1 to 10, remember, if we didn't start at 1, we'd have to use our top minus bottom formula. S sub 10 equals, well, I know the first term because I already did that work to plug that in. Normally, we wouldn't have done that, so we do need to plug in. 6 times 1 minus, my ratio is 2. I'm going to raise it to the 10th, and I'm going to divide by 1 minus 2. Please type it in.
All right. Hold it. What is it?
I will again recommend you do it in those 3 steps.
Honestly, I don't know how.
6, 1, 3, 8.
You should get 6,138 for this.
Oh, that's my teacher.
Excuse me. Your other teacher is waiting for you to stay in here. Next one. Is this geometric?
Sure, because
Yes,
it's
it is.
How do I know?
Because it's to the power of the number.
When the variable is in the power, it's geometric. If I gave you something like this, 0 to 6 of 4i minus 3, that would be arithmetic like what you dealt with last night for the homework, but that's not what we have. So it's geometric. I need to find the first term. So plug in 1. Plug in 0. Plug in that lowest limit. Your first term
4.
is going to be 4 times 3 halves to the 0. 4 times 1, just 4. What's the ratio?
3 halves.
3 halves. The thing we raise to our power is always the ratio. And finally, the number of terms. 765.
7.
7?
6 minus 0 plus
Philip, why 7?
Because you're adding 1.
So what's the whole formula you'd use to find that?
6 minus 0 plus 1.
Top minus bottom plus 1 is going to work for all these sigmas. No, you don't have to show that, but yes, it's going to be 7 there. Well, we have everything we need to use our formula, so please go use your formula. Make sure you put the ratio in parentheses when you type it in, or it will not work properly. And this one, hopefully you can make it into a fraction. If the calculator can't, then you're going to leave it as a decimal, but write the whole decimal out because it will be a terminating decimal.
You guys get.
Approximately. Yes.
Good morning, everyone.
Cameron, do you have a final answer? Were you able to get a fraction first of all?
Yes.
What do you have for the fraction?
2059 over 16.
Good. If your calculator was not able to do that, some versions of the calculator won't work, then you're going to say 128.6875. I'd like you to try the bottom one on your own, and if you needed help with the middle one with the calculator part, call me over and I'll take a look at how you're typing it in. Do I need to come over? Try that last one on your own.
Oh, wait. These are sevens in it.
That's going to take, it's not n minus 1, it's n.
Is that just a mixed number?
I'd prefer improper fractions.
What are you looking for?
First of all, it's not 7. That's the problem.
Please stop, please. We're not gonna
Oh, it's not 6.
Mm.
It's not 6. It's 7 because there are 7 terms. And just be safe, make sure you put that in parentheses in the formula as well. It should be written with parentheses.
Make sure it's in the
When you write, yes. So forget the calculator part, just when you write it over here, put parentheses around the house.
freshman.
Otherwise, technically, it's really only we do
Oh,
and on there as well.
Got it red in.
That's it. You've got an extra negative. Jalen, are you doing that bottom problem?
Okay.
Okay. At this point, I would just stop, I'd push enter, and you got your whole top. And then I'd deal with the bottom. So then, hold on. Okay, so it's telling you the next number, 128 and 11/16. To get this as an improper fraction, you are going to shift this key. That's the mixed number to improper fraction. That's how you're going to write. That's how you Yeah, well, if it doesn't give you a mixed number, if it just gives you a fraction, then that's perfectly fine. But if it gives you a mixed number, use that to convert it to I prefer fractions, please. Yes.
Negative number from last one.
Oh, no. I think it's
That seems reasonable.
Well, then, so the issue is, how many things are in it?
Number of terms, same as yesterday. It's top minus bottom plus 1. We'll give you a number of terms. That's all we're doing. How do you type it in? So I would do 1 minus parentheses 3 halves to the 7. There are 7 terms. Ah. We should be just about done with this one. What was that? No.
Yeah, we'll get
See? Lobby's complaining.
I complain about it too.
Where is it?
I want to talk about it again.
Okay, so how many terms are there? Should be 12 terms. It's geometric. Our first term. Excuse me. What are you plugging in to get the first term? You're going to plug in your lower limit. What is the first term? -2. -2 to the first, -2. Okay, so S sub, how many terms are there? 12. First term is -2. Times 1 minus, the common ratio is -2. That's got to go in parentheses with the 12 on the outside. You're not allowed to combine them and make 1 plus something. What was that? Oh, sorry. And then we're going to do 1 minus -2. When you type that in, you should get 2,730 for this one. The homework, just like for today, will be a mix of the sigma problems and the write it out problems. Okay, before we do anything else, we're going to stop.